mana lah. So yes, this is untuk paraboloid ada berapa surface sebenarnya? Satu surface, lepas tu ada satu lagi which is the cap for your paraboloid here. Another surface. Okay, kalau sphere tadi dia memang ada satu je surface dia which is satu je lah unit normal dia yang kita boleh ada kat sini. But for paraboloid here, let's say paraboloid yang bentuk macam ni, because we have two surfaces here, satu yang paraboloid melengkung ni, so yes kita boleh panggil dia S1. Satu lagi surface yang kat bawah ni, which is you can call it as surface number 2. Okay, so that's why we call it as orientable surface. So kat sini ada dua lah surface dia untuk paraboloid. So that's why unit normal dia kita kena check whether it is pointing positif ke negatif. Okay, konsep dia samalah macam closed curve hari tu. So kalau closed curve hari tu, okay, remember hari tu kita buat line integral, konsep dia sama je macam line integral. If you look at line integral, if it is a closed curve, so let's say curve dia macam ni, 1, 2, 3. 1, 2, 3. So you know this is closed curve, which is curve dia C1, C2, C3. So kita ambil total dia so that you can have your line integral. So same goes for surface integral pun sama. Tengok ada berapa surface kita ada kat situ. And then of course ini closed surface so that it can be a paraboloid. So ini untuk paraboloid. Ellipses, okay, tengoklah dia bagi solid bentuk apa. So tengok ada total surface berapa kat situ, then you can evaluate your surface integral. Okay. For an orientable surface, the gradient vector provides a convenient way to find a unit normal vector. So kat sini involve gradient vector and also sebab kita nak cari unit normal nanti. Yes, ada gradient vector. So let's take a look at apa maksud orientable surface ni sebenarnya. So tengok gambar kat sini, we have figure 1 here, that is orientable surface. So katalah kita ada surface S kat sini, okay, look at your figure 1, ada dua figure kat sini, satu atas satu bawah. That is your surface S. Okay. Sebab tu kita panggil dia orientable surface sebab yang sekeping ni, yes, it can be oriented by the unit normal, positif ataupun negatif. Okay. So kalau unit normal kita menghadap ke atas macam ni, okay, look at the one that has upward direction here. Okay. Unit normal kat sini dia upward direction. Sebab tu anak panah dia letak ke atas macam tu so that you know the unit normal here, it has upward direction. S is oriented in an upward direction. Hence, unit normal kita positif. Okay. So how to find your unit normal here? Yes, look at given to you here, the unit normal n equals to gradient S divided by, ini magnitude, okay, distance, magnitude. Sebab tu saya letak dua palang kat sini, ni maksudnya magnitude. Sebab kalau saya letak satu je macam ni, awak ingat nanti ni absolute, ini bukan absolute, okay. Sometimes it can be written into this notation, sometimes dua macam ni, okay. So that you know this is not absolute or modulus, but this is magnitude. Okay. Ada distance dia dekat situ. So hence the gradient of your S divide by your magnitude of your gradient S. To find your magnitude gradient S, nanti kita check macam mana nak kira. So yes, that's how you know the unit normal for your surface S. This one, it has upward direction. S is oriented in an upward direction. Satu lagi sebab ini sekeping je dia punya surface kat sini. So yes, it also dia boleh jadi juga downward direction. Which is if you have the downward direction here, so unit normal kita ke bawah lah macam ni. Sebab tu dia ada arrow macam ni. This is your surface S and then yes, this is your unit normal. S is oriented in a downward direction. So that's why we have negative here at your gradient, negative gradient S. Okay, so nanti kita nak cari gradient S dulu. So that you can find your unit normal. So itulah maksud dia orientable surface. So ni yang dia tunjuk contoh ni sekeping je lah surface dia, okay. So it can be varies. It must be closed surface, okay, sebab tu dia jadi solid. So yang contoh dia tunjuk kat sini, dia just nak bagi tahu je direction dia macam mana for your unit normal. So now if you look at orientable surface S, so let's say your surface S is given by Z equals to a function in terms of X and Y. Okay. So mana-manalah apa-apa function pun, whether it is for paraboloid ke, lagi kita ada apa solid, cone ke, lagi cylinder, ellipsoid, sphere, okay, it can be any solid that has surfaces. So let's say your Z surface equation here, Z equals to a function in terms of X and Y. So let S is the surface, okay. So sebab tu kita guna S kat sini. S which is in terms of X, Y, Z. Now you can let it as Z minus the function in terms of X, Y, okay. So apa-apa yang sebelah kanan ni awak bawa je pergi sebelah kiri so that you have Z minus F in terms of X, Y. So you must let S as this one. Okay, so that now your S is in terms of X, Y, Z. So X, Y, Z kita semua untuk surface S. Then your S can be oriented by either the unit normal yang ni ataupun yang ni. Upward direction or downward direction. Kena check lah kita punya surface tu macam mana. So ni samalah tadi apa yang saya tunjuk dekat gambar dia tu. So yes, if it is upward direction, the gradient S divided by your magnitude gradient S in terms of X, Y, Z. If your unit normal vector has a downward direction here, your S is oriented downward direction, then yes, kita letak negatif je dekat dia punya gradient. Okay, so that's how you find your unit normal, and depends on your S, whether it is oriented upward or downward. Okay. So ini baru untuk surface yang kalau awak rasa confused lagi, so N here positif ni maksudnya apa? Dia in the direction of your positive Z. So satu lagi yang menghadap ke bawah ni, which is your downward direction, negative here. So unit normal dia sebenarnya dia menghadap ke negative Z, okay. Ikut axis yang mana dia punya direction tu, so that you don't get confused where is your surfaces. So this is application for your surface integral, which is you can find the flux here. Awak boleh baca je sendiri, tak ada apa pun. Dia just nak bagi tahu dia, bagi tahu je this is the application that involve the surface integral. Okay, bacalah. Ni pun sama, yes. Kita panggil dia flux of a vector field F across the surface S. So this is the definition of your flux integral you want to evaluate later on, okay, by using surface integral. So surface integral tadi, yes, kita ada definition of flux integral kat sini. So now this is your flux integral of vector field F across the surface S. So you are given your vector field F, which is in space because we have ijk vector here. So you know this one is surface integral, vector field in space, ada x, y, z. So that's why ada ijk vector here. Once again, komponen dia sama je, mi plus nj plus pk vector. M for vector I, N for vector j, P for vector k. Where your M and P have continuous first partial derivative. Okay, so nanti kita nak differentiate partially. On the surface S oriented by a unit normal vector N. So they related surface S and also unit normal vector n. So the flux integral of your vector field F across the surface S is given by, okay, tengok betul-betul definition of flux integral, how to find the flux integral here. The double integral of your vector field F dot product with unit normal n ds. Okay, ds here stands for surface integral. So note that nanti kita nak guna ni untuk next topic, integral theorems. So ds here is for surface integral. So hari tu kita buat line integral, ada dr kat belakang dia, which is r2 vector lah, dr vector. But this one, ds, this is for surface integral. So you want to evaluate for your surface S. Sebab tu kita ada surface S kat sini. Because this is double integral. So remember kalau double integral, this sama lah macam finding the area. Okay. But because now you have solid here, which is on XYZ plane. So maksudnya nanti kita nak tengok dia punya projection dekat plane mana. Sebab ini double integral. If you are given solid here and then you want to have your projection dekat mana. So that you can evaluate by using double integral. So this is these are some the how to evaluate a flux integral tadi. So ni extended sikit. Okay, from your double integral vector field F dot product with unit normal n ds. So what happened next? So ds kita ni, kita tukar dia into dA, which is this is double integral. You want to find your area. So from here, the surface S will tukar. You want to evaluate the area of your region R. Okay, so what happened to your ds here? Dia sekarang dah jadi dA over unit normal vector n dot product with vector k. Okay, tengok betul-betul kenapa kita kena buat macam tu. Kenapa dA divide by unit normal n dot product with vector k. This is because, baca if your R is a projection of the surface S on the XY plane. Sebab tu kita punya ds ni kita tukar dia jadi dA divide by unit normal n dot product with vector k. Sebab vector k tu ada dekat komponen untuk yang mana. So that's why lagi satu yang belakang ni dia equals to dx dy ni bukannya apa pun, just nak bagi tahu je dA ni awak boleh evaluate dia dx dy or dy dx, up to you. Dia tak ada order pun, okay? As long as depends on how you want to evaluate your area, dx dy ke, dy dx ke, or polar coordinate r dr d theta. Okay, so divide by unit normal n dot product with k. Okay, saya sketch contoh lah kat sini so that awak nampak kenapa kita kena dot dengan k vector here. Okay, macam saya bagi tahu tadi, your R is a projection on the surface S on the XY plane. So X, Y. So let's say, katalah paraboloid yang awak nak cari, hence you have your projection on XY plane. So this is the projection on XY plane. Kenapa kita kena dot dia dengan K? So remember vector field F equals to mi plus nj vector plus k, p vector k, okay. So ini z. So untuk xy kita memang kena dot dia dengan unit normal, dot dengan k vector. Okay. So this one, when you have your projection on XY, kita dot dia dengan K. Sebab direction dia, tengoklah kalau nak kira nanti whether unit normal dia menghadap positif Z ataupun, sebab ni dua surface kan, untuk paraboloid menghadap negatif Z. So that's why kita dot dia dengan vector K. So look at number 2 now. So now depends on your projection. Okay. Sebab sekarang ni awak dah belajar projection tak semestinya on XY plane je. It can be on YZ plane or XX plane. So look at given to you, the surface given to you. So R is a projection of the surface S on the YZ plane. So now let's say sekarang ni surface kita menghadap ada projection dekat YZ plane. Contoh YZ. So ini X, ini Y, ini Z. Contoh dia mana-mana lah. Okay. So now your katalah paraboloid, apa-apa je lah solid dia kan. Okay, so now this is your projection on YZ plane. So that's why for this one, sama je. Surface integral flux vector field F dot product with unit normal and ds equals to. So now look at your R here, the region here is on YZ plane. Okay, so that's why kita kena dot dia dengan I. Kenapa kita kena dot dia dengan I? Sebab if you look at the unit normal now, so okay, cuba tengok unit normal di sekarang. So let's say ini paraboloid, okay. So ada dua surface, satu menghadap positif X, satu lagi menghadap negatif X. Okay, belakangnya of course lah negatif X. So that's why kita dot dia dengan vector I, okay. So yang tadi sebab yang ni unit normal dia pointing positive Z or it can be pointing negative Z. So that's why kita dot dia dengan vector apa tadi? K. So yang ini unit normal je, nanti kita dot dia dengan vector I. Okay, sebab dia pointing positive X or negative X. Okay, sebab tu kena tengok direction, kena tengok dulu projection ni kat mana, surface kita bentuk macam mana. Then you know, yang ni nak dot dengan apa, so and dot with I vector sebab dia punya unit normal pointing positive X or negative X. So same goes for the last one here. This one happens when you have your projection on XZ plane. X, Y, Z. Okay, so let's say XZ, so sebelah belakang ni. So that is your R. Reason you want to find the area because this is double integral. So if you look at unit normal now, so maksudnya unit normal dia, it can be pointing upward here which is positive Y, or also satu lagi surface dia, it can also be pointing a negative Y. So sebab tu kita dot dia dengan vector J. Okay. So look at the surface of, look at the projection you have for your surfaces. So depends the projection dekat mana awak letak dia punya unit vector, nak dot dengan apa. Sekarang awak dah tahu. Okay, based on your projection. So yang tadi n dot with I vector. So this one n dot with J vector. So once again, dy dz ni bukan order dia, okay? It can be dz dy or dy dz, up to you yang mana senang awak nak evaluate. Same goes for dx dz pun sama juga. It can be dz dx or dx dz, up to you. Or it can also be rdr d theta. Jangan lupa bila awak evaluate by using polar coordinate. So bila polar coordinate, order dia memang yang tu je, rdr d theta. You find the radius and also you find the angle of your bounded area. Okay. Are you okay so far?
Okay, Miss. Okay,
Hari
Miss.
Hari Jumaat petang-petang ni kan. Focus Okay, so that's how you evaluate the flux integral, which is we use double integral here, surface integral. So kita tengok surface kita unit normal dia pointing dekat mana, and then we want to evaluate your area. So ni semua tak ada gambar, of course kena sketch sendiri. Sebab yang dibagi ni semuanya boleh sketch sendiri je. So let's look at one by one. We have 1, 2, 3, 4, 5 examples, exercises for today. Kita buat yang mana sempat je lah. Okay. So let's take a look at number 1 first. Okay, a vector field F, xi vector plus 2y, j vector plus 3z, k vector exists over a surface S defined by 2x plus 3y plus z equals to 6 in the first octant. So sebab kita sekarang in chapter 3 now, hari tu chapter 2 semua orang dah belajar, saya pun dah review bentuk macam mana. Hopefully awak ingat lah. 2x plus 3y plus z equals to 6. If you look at your x plus y plus z here, okay, tak ada square pun kat sini, which means that you know this is actually straight line on x, y, z plane. So bila dia straight line, of course bentuk dia nanti macam mana? Yes, this one is actually the solid of tetrahedron. Macam mana nak sketch? Tengoklah awak punya komponen untuk 2x, y, z ni apa. 2x plus 3y plus z equals to 6. So when when x, y equals to 0, okay, sebab awak nak sketch kat mana dia punya intercept tu. When x, y equals to 0, so z is 6. When yz equals to 0, 2x equals to 6, so x is 3. So when xz equals to 0, 3y equals to 6, so y equals to 2. So yes, sambung je lah garisannya. Ini paling basic sekali, tetrahedron. So that's how you sketch your tetrahedron. So if you look at your tetrahedron dia kat sini, nanti saya tunjuk next slide lah. Okay, ni kecil sangat ni. Tapi just nak bagi tahu je how you sketch the tetrahedron. The tetrahedron is on the first octant, okay? So yes, itu first octant, which is positive x, positive y, positive z. Semuanya dekat first octant. So evaluate, please remember the form of your surface integral, okay? Sebab dia tak bagi tahu pun apa. Sama lah macam hari tu bila kita buat line integral, you should know the form of your line integral. Line integral, single integral, vector field f dot with dr. So kalau untuk surface integral mesti ingat ini bentuk dia, double integral vector field f dot product with unit normal n ds. So you know this is surface integral. So evaluate the surface integral over the surface indicated. So macam mana nak evaluate ni? So let's try and okay. Sekejap saya buat page baru. Dah ada dah. Okay, so let's take a look at exercise number 1. Saya pun lupa, saya dah buat. Yes, tadi tetrahedron. So how do you know where is your surface S here actually? So bacalah dia bagi tahu tadi, surface S is actually the one that has the equation of 2x plus 3y plus z equals to 6. So inilah surface S kita. Okay. Because why? Sebab surface ni lah yang ada semua equation x, y, z tu. 2x plus 3y plus z equals to 6. That is your S, okay? Yang menghadap kita ni. Tu surface S, okay? But it is actually, kalau awak tengok tetrahedron ni, it must be closed surface, okay? So that you know this is a solid. So tetrahedron ni sebenarnya ada berapa surface? It is consists of 1, which is yang ada dekat x, z ni, yang sekeping ni, 1 surface. So lagi yang sebelah, so saya lukis saya keluarkan dia. So ni surface 1 sebenarnya. Lagi kita ada apa yang sebelah YZ plane tu. Okay, with surface number 2. Walaupun awak nampak kat sini surface S yang menghadap depan kita ni nampak macam satu je surface, but tetrahedron consists of 4 surfaces. Okay. So yang tadi saya sketch tu yes yang belakang ni lah. Okay. Surface S. So nombor 3 yang sebelah bawah. Okay. So yang ni yang saya keluarkan projection dia. And last one, S ni surface number 4, the one that facing upward kat sini, okay. Yang menghadap kita ni sebenarnya surface S number 4. Walaupun saya tulis nampak macam satu surface je kat sini, but yes, the tetrahedron consists of 4 surfaces, okay. So that you know bila nak cari unit normal dia, yang mana awak nak tengok, okay. Okay. So 1, 2, 3 and then last one here, yes yang S, the one that facing upward here, S kita ni yang segitiga ke depan ni, that is your S. S ni penting, okay, macam mana nak tahu, tengoklah dia bagi tahu kat mana surface S tu. So that is your surface S actually. And then macam mana nak tengok projection dia, untuk soalan ni, yes senang kalau kita buat projection on XY plane, okay. Sebab tetrahedron selalunya yes, kita buat je projection on XY plane. In this case, because the projection is on XY plane, unit normal N, kita dot dia dengan K vector, okay. Sebab projection dia dekat XY plane. So unit normal N dot with vector K. So now observe surface S ni belum habis lagi sebab nanti kita nak kira dia punya unit normal. So look at unit normal here. Macam mana nak tahu unit normal dia facing upward or facing downward? So this is surface S. Okay. So yes, unit normal dia menghadap ke positive Z. Okay. Saya lukis ni nampak macam satu direction je. Okay, it can be macam ni. As long as it is pointing upward. So ni pun sama. Dia selari dengan surface kita ni. Okay, sebab surface kita ni menghadap positive Z. Therefore, yes, unit normal dia pun positive. And okay. As long as it is pointing upward. So in this case, dia selari dengan surface S kita which is facing Z positive. So that's why unit normal N dot with K tadi, vector K. So nanti bila nak cari N dia, unit normal N, okay, gradient S divided by the magnitude of your gradient S. Positif sebab dia menghadap surface S kita ni menghadap positive Z. So satu lagi because it is pointing outward. So unit normal dia upward lah. Positif. Okay. So tu satu. Kenapa N dot with K? Sebab ini projection on XY. Satu lagi unit normal dia yes positif. So gradient S. Lagi satu you must determine your bounded region for your R. So kita dah tahu projection dia on XY plane here, your R. So sketch lah projection R kita which is on XY plane. That's why kita punya unit normal tadi dot with unit normal K. So ni semua orang patut tahu sekarang. So unit, area R senang je which is a triangle here. How do you know the equation for your XY here? Yes, let Z equals to 0. Sebab kita ada surface Z equals to 0 kat sini. You know this is surface Z equals to 0. Okay, so that's why when Z equals to 0, you just substitute into your equation of your tetrahedron here. 2x plus 3y plus z. When Z equals to 0, so sebab tu kita ada 2x plus 3y equals to 6. So rearrange which variable you want to use, up to you. Saya guna y as subject so that I know I want to evaluate by using dy and then dx. Vertical oriented region. Okay, vertical. From Y starts from 0, so this line is Y equals to 0 until it touches upper line here, which is Y equals to 6 minus 2x over 3. So that's why saya nak evaluate guna type 1, which is dy dx. How about your x? X starts from 0 until 3, okay? So semua komponen ni kena ada dulu so that you can evaluate your surface integral. Boleh faham? Ada soalan setakat ni?
Tiada, Miss.
Okay, so type 1 ke type 2 up to you, awak nak evaluate macam mana. So sambung. Kita nak kira dia punya surface integral. After you identify dia punya unit normal yang mana, bounded region dia kat mana, and then now yes, we want to evaluate your surface integral. So given to you, so remember S, surface S tadi dia bagi apa? Sebab tu kita kena tahu surface S tu yang mana so that you know the equation. So in this case surface S dia dah bagi tahu tadi, a vector field F exists over a surface S defined by, so that is your S, which is the surface of your tetrahedron. This is our surface S. Sebab tu saya tulis kat sini, given to you 2x plus 3y plus z equals to 6, let it equals to 0 first, okay? Sebab kita nak kita punya surface S in terms of x, y, z. So yes, next one, let S equals to 2x plus 3y plus z equals to 6. Okay, 6 ni bawa pergi sebelah kiri, so dia jadi negative 6, okay? After that, okay, kenapa kita kena tahu surface S ni? This is important sebab next part will be you want to find the gradient of your surface S. So how to find gradient? Remember, recall balik vector field mula-mula hari tu. To find gradient, you differentiate your S with respect to variable X for vector I. Gradient mesti in vector, okay? How to define for your vector I component here, differentiate S with respect to X. So in this case, 2X differentiate partially. That's why saya tulis D macam ni sebab differentiate partially. So differentiate S with respect to X, you get 2. Okay, sebab yang tu je ada X, yang lain ni of course 0. So that is for your vector I. Plus differentiate partially your S with respect to Y. So differentiate 3Y partially, you get 3. Okay, vektor ni, vektor jangan lupa tulis betul-betul. So last one plus your vector field, for your component for your K vector here, differentiate S with respect to Z. So differentiate Z partially, you get 1. So that's why plus 1K. Okay, selalunya memang kita tak tulis pun 1K. Kita tahu kalau kita tulis K tu, the component here is 1. So that is for your gradient S. Next one, differentiate. Next one, find your magnitude of your S here. Okay, the magnitude of your S, which is the distance. So how to find distance of your gradient S? Dia mesti square root. Okay. So in this case, this sebenarnya gradient. Lemak keluar warna kuning pula. So the magnitude of your gradient S equals to, it is actually the component of your partial derivative respect to X square plus the component for your partial derivative respect to Y square plus the component for your partial derivative respect to Z square. Maksudnya komponen untuk IJK ni ambil je and then awak square kan, tambah semua. That's why you get square root 14 in this case. Make sure you calculate, okay? Sometimes awak ni confident terlebih. Tambah lagi yang ni. Semua orang ingat ni square root 1. Bukan, ini square root 3. Okay, 1 plus 1 plus 1 is 3. So square root 3. Okay. Make sure you calculate, okay. So yes, that's how you find your magnitude of your gradient S. Masukkan je komponen daripada gradient kita ni, so that you can find your distance magnitude. So 2 square, 3 plus 3 square, and then 1 lah kat sini, so 1. So 4 plus 9 plus 1, 14, square root 14, so let it be as this constant, square root 14. No need to have it in decimal, biar je macam tu, square root 14. Okay, ni sebenarnya semua ni kena cari kenapa? Sebab kita nak cari unit normal. Okay, remember unit normal kita tadi, unit normal vector n equals to the gradient of S divided by your magnitude of gradient S. So masukkan je komponen yang awak dah cari tadi. So unit normal n equals to 2i vector plus 3j vector plus k vector divided by square root 14. And then remember, because your projection is on xy plane, therefore that's why we dot product with k. Kena tahu, okay, kalau vector kita dot product, kita buat apa? Multiply with the corresponding component. So n, unit normal n dot with k here. So 2i vector plus 3j vector plus k vector divided by square root 14 dot with k. So apa yang berlaku kat sini? You multiply the same component. In this case, I dekat sini, tak ada pun I dekat sini. So yes, 0, tak ada pun. So make sure bila kita buat dot product, kita cari value, okay? Dia dah tak jadi vector. So 2 multiply with, tak ada pun vector I untuk sebelah kanan ni. So yes, 0. And then J pun sama, tak ada yang awak boleh multiply. So yang hence 0 plus. For K here, yes ada K. 1K vector. So ada lah kat sini, 1 dengan 1. So that's why you get 1 here. That's how you do dot product. Bila buat dot product, memang awak dapat value bukan vector, okay? So 1 multiply with 1, you get 1. So divide by square root 14. Sebab square root 14 tu ada kat situ. So yes, that is unit normal n dot with vector k. So kat sini kita dapat 1 divide by 14. Square root 14. So last one, semua komponen dah ada, masukkan je the double integral of your vector field f dot with n ds. Okay, jangan lupa kita tengah cari surface integral. So masukkan je lah komponen yang kita ada kat sini. So f dot with n dA divided by unit normal n dot with k. Okay, dA ni biar je dulu dA. Tapi dah tahu kita nak evaluate guna apa, which is dy dx. Sebab tadi kita dah set up tadi. Bukan kita, saya dah set up tadi. Okay, dy dx. So yes, nanti bolehlah tukar dy dx dA ni. But first, before you evaluate your dy dx kat sini, make sure you substitute all the component we have here. Vector field F, so tulis balik vector field F dia bagi apa? Vector, okay? And then dot with unit normal n. Komponen yang tadi yang kita dah ada tadi. Multiply with dA divide by unit normal n dot with k. So semua komponen yang ada tadi tu masukkan je dalam surface integral. So what happened here after you substitute all the component into your double integral? Observe, okay? Apa yang boleh cancel kat sini, which is yes, unit normal n tadi dia ada divide by square root 14 kat sini. So multiply with this one, which is your unit normal n dot with k here, 1 over square root 14. Refer balik previous slide tadi. Of course this one boleh simplify. Dia mesti sama, so that you can cancel out macam ni. So square root 14 multiply with 1 over square root 14 because both are at the denominator. So sebab tu awak boleh cancel macam ni. Hence, dia jadi 1. Okay, so that's why continue. So what happen next? Sebab ini dot product sama lah konsep macam saya bagi tahu tadi. Sebab dot product awak mestilah multiply the same component. X dengan multiply with 2 here. So you get 2x. And then lepas tu mesti plus because this is dot product. Plus 2y multiply with 3, multiply komponen yang sama. Okay, this is for vector J. So 2y multiply with 3, you get 6y. Plus, so the last one you have here, 3z multiply with the component for your k here, which is 1. So that's why you have 3z. Okay, so that's how you do dot product. Ini, please know the concept here. This is the dot product between vectors. So that's why dia dah tak jadi vector, lepas tu dia jadi equation macam ni je. In this case, you have 2x plus 6y plus 3z dA. So do not forget we are evaluating double integral dA here, which means that kalau dA dia mesti ada x and y je sebab ini double integral. So that's why z dekat sini you must substitute z with, mana datang z ni? Mana datang z equation ni?
Tetrahedron.
Yes. It comes from the tetrahedron equation tadi, okay? Refer balik. Let z as subject sebab awak nak substitute z. So z equals to 6 minus 2x minus 3y. So that's why bila nak evaluate dalam double integral, you must substitute your z here with 6 minus 2x minus 3y. So that lepas tu barulah boleh evaluate with respect to y and x. Dia mesti in terms of x and y. Because you want to evaluate dy dx here. Okay, so mesti substitute. So substitute your z tetrahedron, let z as subject. So barulah boleh integrate lepas tu, okay. Letak boundary sebab tadi kita dah set up siap-siap tadi. Make sure you have the correct boundary. In this case, saya evaluate dy dulu, lepas tu dx. So yang ni senang je sebab dia dy dx. Expand and then integrate. You should get answer here 36. So the surface integral here, answer is 36. Macam biasa, continue on your own the integration part. Okay, saya guide awak untuk set up je. Integration tu of course lah awak kena sambung sendiri. Any questions so far? Exercise number 1.
No, Miss.
No, madam.
Okay, so look at your surface S, unit normal dia, positive ke negative, and then yes, you just substitute into your surface integral. Of course, it is related to area. So tengoklah projection awak kat mana nak evaluate, check. In this case, tetrahedron ni, sebab unit normal dia, surface kita menghadap positive Z, so unit normal kita pun pointing upward. Hence, ambil je projection on XY plane. So make sure awak substitute betul-betul yang gradient S dengan magnitude ni. Apa saya nak bagi tahu tadi? Square root, okay? Square root and then ada square kat dalam tu. Make sure you square first and then you just add on the value. So biar je macam tu, square root 14. And then janganlah confident sangat square root 14 equals to 7. Ni pun salah juga. Lagi, square root 1 of course lah equals to 1. Please write it as 1 kalau square root 1, okay? Lagi ada apa? Square root 4 equals to 2. Okay? So that easier nanti lepas tu bila awak nak evaluate. Tapi kalau tak boleh evaluate square root tu jadi berapa, let it be, okay? In that form. Square root 14 kat sini, yes, square root 14. Okay. So example 1 done. Make sure you do the integration here until you get your answer, which is 36. So now let's move on to number 2. Number 1 tadi okay? Dah salin ke?
Dah.
So now let's try number 2. Okay, so for number 2, tengok pun dah tahu nak evaluate guna polar sebab it involve circle here because we have paraboloid. So evaluate the double integral. So the question asks you evaluate the double integral. That's why we have vector field f dot with unit normal n ds of your surface S, where your f given to you the vector field y I vector plus x j vector plus z k vector, and S is the boundary of the solid region E enclosed by the paraboloid. So dia bagi paraboloid kat situ, tengok paraboloid awak bentuk macam mana, yang macam tu ke, yang satu lagi. How do you know your direction of your paraboloid here? Because yes, you know direction dia, tengok je dekat Z ni. Z equals to, you know that we have 1 minus x square minus y square here. It can also be written into 1 minus x square plus y square in bracket. Because we have minus here, so that's why paraboloid kita bentuk macam ni. Paraboloid ni datang dari parabola kan. So that's why sebab ada negatif kat sini, so sebab tu kita punya surface of paraboloid macam ni. Okay, sebab dia negative. So now yes, let's try to evaluate the surface integral here. Of course by using polar coordinate. Because why? Look at the projection here. Projection dia on xy plane. So yang ni pun sama juga on xy plane. So S dia yang mana? S is the boundary of the solid region E enclosed by the paraboloid. And the plane Z equals to 0. So ini paraboloid. So kita ada dua surface sebenarnya. Satu surface yang kat bawah ni which is the cap of your paraboloid. So ini surface 1 and then satu lagi surface S, your paraboloid surface here which is Z equals to 1 minus x square minus y square. So tadi tetrahedron ada 4 surfaces sebenarnya. So ini untuk paraboloid ada dua je. Satu yang kat bawah which is Z equals to 0. Satu lagi the surface S here which is your paraboloid. Z equals to 1 minus x square minus y square. So you know that is your S. So now look at your direction of your unit normal here. Once again, ini pointing upward juga. Sebab apa? Projection on xy plane. Okay. Because your surface S here is pointing positive Z, therefore unit normal dia pun pointing upward. Okay, ikut surface S awak tu menghadap sebelah mana, so then you decide the unit normal is positive sebab dia pointing outward of your surface S. Okay, so and yes, unit normal ke atas, ni ialah unit normal awak. So lagi apa nak kena kira kat sini? Yes, boundary now. Okay, so set up dia punya polar. Because this is a paraboloid, so senang je. When Z equals to 0, substitute into your equation of your paraboloid here. So that's why kita dapat x square plus y square equals to 1. So you know the equation of circle is actually x square plus y square equals to 1. So you know this is the equation of circle. Where your radius is 0 until 1, okay? Because this is r square equals to 1, hence r is 1. So radius for your circle here, 1 center at 0, 0. How do you know it is center at 0, 0? Yes, sebab ini x square, maksudnya x minus 0 square plus y minus 0 square equals to 1. Therefore radius is 1, center at 0, 0 sebab x minus 0, y minus 0. So kita tahulah origin dia dekat 0, 0 center. Okay, so ni senang je sebab di circle polar starts, the radius starts from 0 until 1. It is bounded by radius 0, 1 and then theta dia 0 until 2 pi. So yang ni senang je. And then buat apa? Yes, calculate your double integral, the surface integral. Determine first your S. In this case, tadi saya dah bagi tahu S dia yang mana, sebab tu saya tulis S ni. S is actually the paraboloid. Z equals to 1 minus x square minus y square. So given your Z here, your paraboloid surface, so let it equals to 0 first so that you can let it as S. So S equal to Z minus 1 plus X square plus Y square. So bawa je lah yang sebelah kanan ni pergi sebelah kiri. So that's why you get your surface S as such. And then sama je konsep dia. Differentiate your component here so that you can have your gradient. Tadi saya guna notation derivative, partial derivative tu. Yang ni pun boleh. Okay, make sure you write it as subscript. So that we know that is partial derivative. So differentiate partially x, y, z so that you can have your gradient s. So in this case, differentiate x square dapat 2x. So this is for vector I. Differentiate y square dapat 2y for vector j. Differentiate z with respect to z, you get 1 which is vector k. Okay, so nak senang, awak boleh tulis vector as in this form. Okay, gradient tadi boleh tulis dia, saya tulis macam ni pun boleh juga. Okay, so that you know this is also a vector. So bila tulis yang macam ni, yes, nanti nak lagi senang nampak awak nak dot product apa. Because this is vector also. Okay. Example tadi saya guna IGK. In this example, yes. Sama je, you can write your gradient SS. The component for your IGK here. 2x, 2y and 1. Okay, component for I is 2x, component for j is 2y, component for k is 1. Lepas tu sama je lah, cari dia punya gradient. So the gradient here is 2x square plus 2y square in bracket plus 1 square. So in this case, in magnitude kita bukannya value tapi a function, okay? Depends what you have for your gradient S tadi. So masukkan je dalam kita punya magnitude of your gradient S. So hence you get 4x square plus 4y square plus 1. So that is your magnitude of your gradient S. Masukkan je into your unit normal so that you can have your unit normal here. So gradient S divided by your magnitude gradient S. That is your unit normal n. Unit normal n dot with k. Okay. Boleh tulis macam ni. So ini untuk unit normal 2x to y. 1 dot with, yes, ini k. Sebab tu kalau nak tulis macam ni, dia mesti ada komponen untuk I dengan J. So 0, 0, 1. So you know yang mana awak multiply. So this one multiply, you get 0. This one multiply the component for I, you get 0. And then you left with for K only, which is 1 multiply with 1, you get 1. So N, unit normal N dot with K vector. This one you get, okay. So nanti nak substitute dalam kita punya surface integral, jangan lupa kita nak guna yang ni dengan yang ni. So that's why find first. So that easier bila nak substitute dalam surface integral. Are you with me? Are you okay so far? Ada soalan nak tanya? Ada kat mana-mana tak faham?
Setakat ni okey, Miss.
Alright.
Okay, Miss.
Okay, cari dulu semua ni so that easier bila nak masukkan dalam surface integral. Buat asing dulu and then masukkan. Kalau awak masukkan semua sekali dalam ni, yes, nanti salah. Check dulu one by one, okay. So in this case, masukkan je vector field F kita tadi apa? Cuba check balik soalan vector field F, Y, X, Z. Okay, given to you vector field F tadi. Okay, it can be written into this form also. Y, X, Z. Vector. Dua-dua ni sama. So sebab tu saya guna yang tu. Yes?
Saya nak tanya, kenapa yang kalau dekat slide sebelah tu, slide before this, kenapa dia tulis 2x, 2y, 1 instead of plus? Yang darab dengan okay.
Yang ni?
Kenapa dia comma instead of plus?
Sebab vektor. Okay, recall balik mula-mula masa kita belajar chapter 3. Mula-mula sekali hari tu saya dah bagi tahu. Vector, it can be written into two notation. Satu macam ni. Okay. Vector kan. Satu lagi or macam ni. 2x, 2y, 1. Okay. And then notation untuk vector yes yang ni. Bukan bracket biasa tapi bracket macam ni. Dua-dua ni sama.
Oh,
Apa yang
okay Miss.
Boleh faham?
Boleh. Saya terlupa.
Yeah, sebab kita selalu guna IJK tu. Kan? So yang bila untuk surface integral ni, it is easier if you write yang ni sebab kita ada banyak calculation lepas tu. Sama juga sebab bila nak masuk dalam integral nanti. So make sure bila nak tulis dalam notation yang macam ni, make sure kita tulis komponen dia je. 2x, 2y, 1. Make sure ni betul lah. So that we know this is also vector. Kalau awak tulis macam ni salah, okay? Kalau bracket biasa ni, okay, make sure you have the correct notation when you want to have your vector. Kenapa saya guna yang notation ni sekarang? Yes, sebab bila awak nak dot product, sebab kat sini ada banyak dot product, so make sure awak tulis. So same goes for vector K kat sini. Tadi saya bagi tahu you must dot with vector K, right? Unit normal N dot with vector K. So vector K nak tulis macam mana? Yes, in this notation macam ni lah notation dia. Awak tak boleh tulis satu je. Sebab ini also a vector. So vector untuk K seorang-seorang je, it is actually 0, 0, 1. I tak ada, C tak ada tapi dia ada K je. So that's why tulis macam ni. So that you know. Bila tulis macam ni awak nampaklah komponen nak kena multiply. Okay. Boleh faham?
Boleh Miss, thank you.
Okay. Okay, so let's continue ni tadi balik. So yes, vector field F pun sama. Saya tulis macam ni sebab nanti senang nak masukkan dalam integral vector. Okay, so this one vector field F, which is the component for I is Y, component for J is X, component for K is Z. Dot product, okay. So bila dot product, bila awak tulis macam ni, awak nampaklah nak multiply apa. Okay, multiply the corresponding component. Komponen yang mana, multiply yang mana, lepas tu tambah. Okay, bila buat dot product memang tak ada dah vector. Lepas tu, it become equation biasa je. So Y multiply with 2X, you get 2XY and then plus. X multiply with 2Y, you get 2XY and then plus. Z multiply with 1, you get Z. Because this is dot product. So once again, masukkan je komponen. So ni, yang komponen tengah ni, vector unit normal N. And then dA divide by unit normal N dot with K tadi, yang kita dah kira tadi, 1 divide by the square root of this one. So yes, boleh cancel out, boleh simplify. So cancel. Because both are at the denominator. So bolehlah cancel sebab tu awak dapat 1 je kat situ. Make sure you know, masukkan ni baru awak cancel, okay? Show how you substitute into your surface integral. Okay, masalah calculus ni bila semua students tulis shortcut. Dekat mana nak bagi markah lepas tu? Okay, make sure you show how you get to your equation. Sebab markah ni kita tak tahu dia nak letak kat mana. So tunjuklah awak buat macam mana. Okay. And then yes, evaluate je, sambung je tadi awak dah dapat tadi. 2xy plus 2xy plus z dA. Jangan tak tahu pula ni boleh tambah 2xy plus 2xy. So you get 4xy plus. So z ni samalah macam saya explain tadi. It must be in terms of xy so that you can evaluate your double integral. So z. So z ni dapat mana tadi? Yes, from your paraboloid. Okay, so z equals to 1 minus x square minus y square. Saya tulis siap-siap macam ni sebab saya tahu x square plus y square is r square sebab kita nak guna polar. So you just substitute z with 1 minus in bracket x square plus y square. So at this stage dA ni belum convert lagi sebab semuanya in xy and because we want to apply polar, so yes, lepas tu baru convert to polar. So bila convert polar, semua orang tahu x you must substitute with for r square, r cos theta, y mesti substitute dengan r sin theta. So multiply ni sebab for xy plus 1 minus x square plus y square is r square. So 1 minus r square. So dA jangan lupa because this is polar. Yang tu pun sama, tukar. dA now in polar r dr d theta. Okay, make sure be careful with the bracket here. Kena expand dulu. Multiply dulu with your r kat sini sebab ada banyak komponen kat sini. So please continue on your own. Boundary tadi dah set up sama. Radius starts from 0 until 1. Theta starts from 0 until 2 pi. Continue. Evaluate the integral until you get the answer here. Pi over 2. Boleh?
Boleh, Miss.
Boleh, Miss.
Ada siapa-siapa ada soalan, tanya jangan tak tanya. So this one, number 2, you evaluate the surface integral. Kita apply polar sebab dia circle kat sini. Dia punya projection is a circle. Sebab ini double integral, ada dua je possible awak nak evaluate guna apa. Whether polar coordinate or Cartesian coordinate. Okay, so if you are okay with exercise number 2, let's. So ada example lain lah yang mana tadi. Number 3, 4, 5. Okay, so kalau tengok number 3, paraboloid sama je. Number 3 lebih kurang je dengan number 2. Macam mana nak tahu paraboloid dia bentuk macam mana? Tengok equation dia bagi. So z equals to 1 minus x square minus y square. So samalah bentuk dia macam number 2 tadi. So you can try it on your own. Above xy plane, maksudnya apa? Z equals to 0. Okay, please try number 3 as your homework. Answer saya dah bagi. Ini sama je dengan number 2 tadi. But the component for your vector field F lain. Okay. So evaluate your double integral. You should get answer here is 2 pi. So evaluate by using polar coordinate. If you look at number 4 pun sama juga. Kalau number 4, ini sama dengan number 1 because you are given the plane x plus y plus z equals to 1 which is a ni equation apa ni? Ada siapa-siapa tahu? X plus y plus z equals to 1. This is the trihedron. Sama macam number 1 tadi. But in this case, the trihedron kita, dia punya intercept sebenarnya dekat 1 sebab x plus y plus z equals to 1. So 1, 1, 1. So ni pun sama, ni surface S kita. Sama macam example 1 tadi. Okay, number 3 tadi sama, surface S kita paraboloid. Dia punya equation of your paraboloid. So this is your surface S. So ni tetrahedron, ni lah surface S kita. Okay, please try until you get the answer. Answer is 4/3 for number 4. Okay, make sure awak buat exercise, practice so that you know how to evaluate surface integral. Calculus ni kalau awak tak cuba buat, awak tengok je ada jawapan je. Sampai bila awak nak tahu. So make sure you do so that you know. Ada jawapan pun belum tentu awak boleh buat. Kalau awak tak, practice. So 3 and 4, please try both as your exercises, as your example. Saya nak suruh awak buat number 5 sekarang. Okay, ada setengah jam lagi. So let's try number 5 now. Find the flux of the vector field F. In this case, vector field kita ada komponen K je. Z, vector K. Maksudnya IJ 0. So dia bagi K vector je, which is Z. Through the surface S, where S is the first octant portion of the paraboloid Z equals to x square plus y square that is cut off by the plane Z equals to 4. So ini paraboloid tapi sebenarnya dekat first octant. And it is cut off by the plane Z equals to 4. So if you look at your equation of your paraboloid here. Okay, apa beza paraboloid ni dengan example 2 and 3 tadi? Cuba tengok equation yang dia bagi. Observe. Apa beza dia dengan number berapa tadi paraboloid? Number 2. Number 2 dengan number 4, number 3 sama lah. Apa beza dia sekarang ni paraboloid kita?
Dia tak bagi radius.
Pendudukan dia. Dia betul-betul atas plane Z.
Lagi? Ada siapa-siapa ada idea lagi? Nampak beza dia? Yes, satu nampak macam tak ada radius sebab yang paraboloid tadi tu ada 1 minus something. Yang ini ada Z equals to x square plus y square. Beza dia kat sini, ini positif, number 2 tadi negatif. Tu beza dia. Z equals to x square plus y square, depan dia ni positif. Okay, sebab yes, memang positif. Hence, paraboloid kita bentuk macam mana? Bentuk ke atas. Sebab dia positif. Yang tadi kenapa bentuk dia macam ke bawah tu? Sebab dia
Negatif.
negatif. Yes. Negatif di depan ni, okay. So that's how you do your orientation of your paraboloid. Sebab kalau awak salah sketch, salah lah awak punya S tu nanti, okay. So yes, in this case number 5 paraboloid kita bentuk dia ke atas macam ni sebab dia positif, okay. Tu je saya nak bagi tahu. Macam mana nak tahu radius dia? Cuba tengok Z sekarang. Satu lagi Z dia bagi, it is cut off by the plane Z equals to 4. Okay, ni tak cukup space ni, tak apa. Kita buka satu page lagi. But you know that is paraboloid and then tapi dia bagi tahu it is in the first octant. So maksudnya first octant ni je. And then it is cut off by the plane Z equals to 4. So maksudnya Z equals to 4. Yes, atas ni 4. So bila nak tengok projection dia, barulah kita tahu dia punya radius berapa sebab ini Z equals to x square plus y square. Satu lagi Z equals to 4. So when Z equals to 4, you get x square plus y square equals to 4. Then you know projection dia mesti circle. Hence you get your R from here because x square plus y square is R square. Kalau yang tadi number 2 dengan number 3, Kenapa awak let dia equals to 0? Sebab yes, info kat sini z equals to 0. Same goes for number 3 pun sama. Above xy plane which is the plane of z equals to 0. Sebab tu dia bagi equation macam tu. But for number 5, walaupun dia tak bagi berapa, tambah berapa kat sini, but you have another info here which is z equals to 4. So when you equate both, it become x square plus y square, then you know the radius. Boleh faham dah sekarang?
Boleh.
Boleh.
So now, cuba kita sketch dulu. Saya nak suruh awak buat ni. Sekejap. Number 5. Okay, number 5 tadi. Let's sketch. Sketching ni, kalau sketch bagi clear, okay? Kat mana, axis kat mana, bounded solid kat mana, projection yang mana. At least shade dia punya region. Awak lukis tak cantik tak apa, tapi make sure dia punya tu betul-betul. Okay, so yes, because this is parabolic macam saya bagi tahu tadi, bentuk dia macam mana. Sebab dia mention in first octant, hence yes, yang tu je, which is on the first octant. Cut off by the plane z equals to 4. So yes, yang atas ni z equals to 4. Surface sekeping z equals to 4. So itulah kita punya solid kita kat sini yang dia bagi tahu info tadi. So ni z equals to 4, okay. Straight je plane dia, which is z equals to 4. Parabola kita yang kat bawah tu, which is this one. And if you look at your parabola here, dia sebenarnya consist of berapa surface kat sini? 1, 2, 3, 4, okay. Ada 4 sebenarnya. Sebab dia dah cut off. And then dia beritahu it is on first octant. It is in first octant. Mana datang 4 surface ni? So yes, yang belakang ni 1, yang tepi ni 1, and then atas lagi 1 yang surface parabolic kita, which is your z equals to x square plus y square. The parabolic. So yang ini atas tu z equals to 4. Soalan saya kat sini, mana satu kita punya surface S equation? Can you determine?
Yang curve tu je.
Yang curve. Lagi? Ada siapa-siapa ada idea yang lain? It's okay, tak apa, bagi tahu je. Saya nak tahu awak rasa yang mana tu je.
Z equal 4.
Z equals to 4. Sebab kita ada 2 equation kan kat sini, so awak tak tahu yang mana. Actually both are correct, dua-dua surface dia. Maksudnya ada surface S1, surface S2. So S1 ini S2. Okay. Maksudnya nanti kena cari 1 untuk surface S plus 1 untuk surface 2. Kenapa kita tak cari yang surface belakang ni? Yang tepi sebelah YZ dengan XY ni, kenapa kita tak cari juga? Because yes, itu surface 0. Okay, ini surface apa? Y equals to 0. Ini surface apa? X equals to 0. So bila kita cari dia punya gradient, of course gradient dia 0 sebab tu surface kat sini 0. Yang ni pun sama, Y equals to 0. Bila awak cari gradient, of course 0 juga. Sebab tu kita tak cari sebab you know, nanti dapat surface integral dia 0. Tapi untuk Ini kenapa kena cari dua-dua? Yes, sebab S1 dengan S2 dia ada dua surface tadi. Okay, jangan confuse dengan tadi exercise kita buat tadi. Cuba tengok balik exercise tadi. Apa Miss tak tunjuk pun tadi, padahal tadi ada banyak surface. Okay, now let me explain. Number 1 tadi. Kenapa saya kira satu je surface kat sini? Yes, because ini surface apa kalau awak tengok yang warna hijau ni? Equation dia apa?
Y
Y.
0.
Yes, y equal to 0, which means if you find the gradient dapat 0 nanti. Okay. So yang kuning tu pun sama juga. Ini equation apa? X equals to 0. Plane X equals to 0. So sama juga. If you find the gradient, you get 0 sebab equation plane dia X equals to 0. Same goes for Z equals to 0. Sebab tu saya bagi tahu kena check ada berapa total surface sebenarnya. So when Z equals to 0, yang saya dah tulis kat sini tadi, yang bawah tu base dia. So that's why gradient dia pun 0. So that's why S yang kita ada yang ni je. Okay, dah boleh nampak dah. Apa maksud surface integral sebenarnya? Okay. Sebab tu kita kena check ada berapa total surface integral dulu. Okay, so that is for number 1 tadi, tetrahedron. Kalau tengok number 2, yang ni pun sama. Dia ada dua surface je, which is saya bagi tahu tadi, S yang parabola kita, satu lagi surface apa? Z equals to 0. Okay. Sebab tu kena tengok total surface ada berapa dulu. So in this case, when Z equals to 0 for this surface, so because Z equals to 0, bila awak cari gradient dia pun awak dapat 0 nanti. Okay. So that's why kita kira untuk S yang atas ni je. Boleh faham?
Boleh Miss.
Boleh Miss.
Okay. So back to our, so tadi example 3 dengan 4 boleh cuba sendiri sebab example 3 dengan 4 dia sama dengan example 1 and 2 tadi. Tapi untuk example number 5, ya saya kat sini extra sikit. Sebab tadi kita asyik kira unit normal positif je kan. So now let's check. Masa bila unit normal dia negatif. So S1, S2. So maksudnya kena cari untuk S1 tambah S2. Konsep dia macam line integral hari tu. Bila ada close curve, awak kira untuk semua curve and then awak total. So ni pun sama lah konsep dia sebenarnya. So Y equals to 0, X equals to 0 tak payah kira sebab nanti dapat 0. So surface yang kita nak kira kat sini S1 dengan S2. So if you look at S1, unit normal dia positif, okay? Gradient S positif divide by square root S. S2?
Negatif.
Yes, negatif. Sebab dia pointing negative Z. So surface kita ni menghadap negative Z. So yes, unit normal dia pun negative gradient S divide by magnitude dia. Boleh faham dah sekarang? So look at the surface tu macam mana dia menghadap mana. So ada dua surface kena kira kat sini. So panjanglah sikit jalan kira dia. But let's determine first dia punya boundary dulu. Boundary area, boundary area. Yes, ni boundary area kita. On XY plane. So this is our R. Okay. Which is bentuk dia quarter circle. So that is our R. So you know ini equation apa tadi? Z equals to X square plus Y square sebab kita ada Z equals to 4 juga. Hence this is actually X square plus Y square equals to 4. So R square is 4, radius is 2. So theta angle kat sini 0 until pi over 2 je sebab dia 90 degree sebab dia first altern tadi dia beritahu. Hence it is on first quadrant kat sini on your XY plane. Okay. X, Y. So we know we want to apply by using polar coordinates. So radius start from 0 until 2. Theta starts from 0 until 2 pi. So ada banyak komponen awak kena kira kat sini sebab ada dua surface sekarang. Satu gradient S untuk surface 1, satu untuk gradient S2. So buatlah satu-satu, panjang kat sini. Boleh awak cuba cari dua-dua ni, boleh sekarang. S1 apa, S2 apa. So S1 kita punya equation dia apa? Z equals to 4. So Z minus 4. Okay, sebab kita ada plane Z equals to 4. So
Theta sampai 2 pi, madam.
sorry, pi over 2. Pi over 2. So plane Z equals to 4. So let Z minus 4 equals to 0. So kita dapat kita punya S. So which is saya namakan dia S1. So S1 equals, S1 here is actually Z minus 4. Okay, equals lah kat sini. Kenapa saya letak dot kat situ? So S1 equals to Z minus 4. So itu untuk S1, satu lagi S2. Which is your surface. Z equals to X square plus Y square. So Z minus X square minus Y square equals to 0. Biar dia jadi 0 dulu. So that now you can have your surface 2 equation which is Z minus X square minus Y square. Boleh cuba sekarang?
Boleh.
Okay, please try now. Kira betul-betul, okay? Sebab ada banyak komponen nak kira ni. So S1 Z minus 4 equals to minus 4. S2 Z minus X square minus Y square. So for S2 jangan lupa unit normal dia ada negatif dekat gradient S. Please try now, nanti kita check jawapan. S1 dapat apa, S2 dapat apa. If you have any question boleh tanya, okay? Dah sampai mana dah?
Untuk S2
S2, okay. Yes, S2 tu panjang sikit sebab unit normal dia ada komponen kan XY tu. Okay, tak apa, take your time. Buat sampai habis, tengok nanti kita check jawapan awak. Ada siapa-siapa lupa nak off mic ke? Okay, check the component you substitute into your surface integral equation formula here. Surface integral kita. Check komponen dia sama tak dengan saya? Apa yang awak substitute tu? Okay, when you substitute your boundary here, sama je dua-dua ni surface dia, boundary je dia still sama. Tak ada apa yang lain, cuma surface S kita kat sini je yang lain, which is the surface integral. So kat sini you get, saya tertinggal apa kat sini? Oh, Z, sorry. Okay, because your vector field F here is Z for vector K. So Z je lah ada kat situ. So hence your integral here, it becomes Z TA. So ini untuk S1. Macam mana nak evaluate ni? Because we want to use polar coordinate here, R dr d theta. So radius is 0 until 2, 0 until pi over 2. So what happened to Z kat sini? Awak nak substitute dengan apa sebenarnya?
Empat.
4.
Yes, substitute Z equals to 4. Sebab ini surface 4, Z plane Z equals to 4. So substitute Z with 4. Yes, you evaluate 4 nanti. So R dr d theta ni senang je integrate. You should get at this surface S1, you evaluate the surface integral, you get dapat apa?
4 pi.
Yes, 4 pi. So that is for surface 1. So surface 2, the paraboloid surface here, yes, ni komponen dia. Sorry tak cukup space kat sini, saya tulis je lah. So yes, the one that you multiply here is Z. So ini boleh simplify, okay. Yang bawah-bawah dia tu sama je. Minus Z, sorry. Sebab Z multiply with negative 1 sebab dia punya gradient kat sini negatif kan tadi, jangan lupa. So yes, negative Z dA. So set up for your dA here because we want to use R dr d theta, the polar coordinate. So boundary dia sama tak ada apa yang ubah sebab projection dia sama je. But now Z kat situ awak nak substitute dengan apa?
R.
Yes, Z equals to X square plus Y square which is equals to R square. Bukan R je. Yes, R square. Minus ada ni, sorry lupa. So kat sini jawapan dia apa? Dah dapat untuk S2.
Saya tak dapat, madam.
You should get negative 2 pi. Ada siapa-siapa dapat negative 2 pi? Okay, tak dapat tu sebab apa? Ada salah apa-apa ke kat mana-mana?
Saya salah tengok equation. Saya pergi sub balik masuk yang Z is equal to 4.
Oh, okay. Check balik surface apa? Yes, sebab sekarang ada dua surface lain kat sini.
Okay, madam.
Okay. Okay, sebab kita ada dua surface berlainan dekat sini. So S1 untuk plane Z equals to 4, S2 untuk the paraboloid. So check Z apa yang awak nak substitute kat sini. So last one, S1 plus S2 which is 4 pi untuk S1 minus 2 pi untuk S2. Answer is the surface integral here is 2 pi. Okay. Siapa yang tak dapat tu check lah balik awak salah apa-apa kat mana. Adalah tu. Mesti ada. Alright, so that's all for surface integral. That's how you do your surface integral. Look at the orientation of your S and then check the unit normal whether it has positive unit normal or negative unit normal. So tu je. And then how to find your unit normal? Gradient S divided by the magnitude of your gradient S. And then substitute je dalam surface integral. Jangan lupa form dia double integral. You want to evaluate of your surface S, vector field F dot with unit normal and ds, okay? Because it is double integral, then we want to find the area. So kita tengok projection dia kat mana. So next lesson will be, kita sambung next week. So next week, last week 14, week last, okay. Make sure please be on time. So make sure awak buat dulu surface integral ni sebab bila kita nak masuk next lesson, which is the integral theorems, yes, kita nak apply benda yang sama but for Stokes theorem and also divergence theorem. Any question? Ada soalan ke nak tanya? Tak ada.
No,
Okay, kalau tak ada, that's all for today. See you again next week. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Miss.
Thank you, Miss.
Salam. Sama. Ya, sama.
Thank you, Miss.
Thank you, Miss.